Groundbreaking developments in space exploration are unfolding. Newly released footage of the S-33 reveals key details about its explosion. We'll analyze the findings and their implications. Meanwhile, the vast space station module has reached a major milestone, and NASA's Artemis II preparations continue to accelerate. Join us on today's episode of Great SpaceX as we go over these critical updates. The destruction of S-33 remains a highly debated topic, particularly regarding its impact on Starship's development and the state of its technology. However, regardless of the controversy, there is no denying that the explosion itself created a striking visual spectacle. The key question remains, what exactly happened leading up to that moment? Given the significance of a Starship launch, multiple cameras captured the event from different angles. Recently, new footage was released on X by ABC 13 News WSET, offering another perspective on the incident. In the first 9 seconds of the video, S-33 is still intact, flying as expected. However, as it passes through a dark cloud, the explosion occurs. Based on previous analyses, this aligns with the moment SpaceX activated the flight termination system. Initially, the explosion is immense and clearly visible, lasting approximately 8 to 9 seconds before weakening and breaking into smaller fragments. This sequence aligns with widely shared footage from other sources, which captured debris from S-33 streaking across the sky like fireballs. Despite the dramatic visuals, this particular footage makes it slightly difficult to see the ship itself due to the thick cloud cover and the explosion's brightness. However, it provides a compelling sequence of events leading up to, during, and after the explosion, offering a unique perspective on the incident. The release of this footage has sparked widespread discussion. Many viewers have expressed their astonishment at the event's intensity, despite the unfortunate outcome. However, while the visual spectacle is undeniable, it is important to remember that no one wants such failures to occur. Each explosion represents a setback, revealing technical challenges that must be addressed before Starship can become a reliable vehicle for space exploration. Following the flight, extensive analysis has been conducted to determine the cause of the explosion, the sequence of failures, and the broader implications for Starship's design. SpaceX later confirmed on its website that a fire occurred in the aft section of S-33, ultimately leading to what they termed a Rapid Unscheduled Disassembly, or RUD for short. Elon Musk provided additional details, explaining that an oxygen and fuel leak in the cavity above the ship's engine firewall led to a pressure breach. Technical assessments suggest that the issue likely originated in a methane pipe connecting the main fuel line to the engine's turbine pump system. This pipe, positioned above the firewall, as Musk described, is particularly vulnerable due to its curved shape and location within the dome system. The dome is a critical structural element where the engine directly interfaces with the fuel systems above it. Initially, the leak may have been minor, but as it expanded, it likely compromised surrounding components. The buildup of pressure may have exceeded the venting system's capacity, allowing the leaked fuel to come into contact with the engine flame, igniting a fire. The first sign of failure appeared at T plus 7 minutes and 39 seconds when the first sea-level gimbal engine malfunctioned, as seen in the live broadcast. This initial engine failure triggered a series of cascading issues. The explosion of the first engine likely generated a shockwave that, along with the fire, impacted nearby systems, particularly the starboard aft flap and adjacent engines. Soon after, the second sea-level engine failed, followed by the 2 vacuum-optimized engines on the same side. With only 2 engines on the left still functioning, S-33 lost stability. At that point, the FTS system was triggered, resulting in the explosion captured in the new footage. The entire failure sequence unfolded over approximately 4 minutes, with S-33 predicted to have exploded at around T plus 11 minutes and 30 seconds. Another detailed analysis suggests that the explosion occurred behind the smoke cloud in a way that caused the vehicle to split into 2 major sections. The FTS system is centrally located, meaning the detonation likely severed S-33 along its midsection. This theory is further supported by footage showing debris trails of 2 distinct colors. Some debris displayed a prominent red-orange hue, while others appeared blue-white. The difference in coloration suggests varying material compositions between the two halves of the vehicle. Following the breakup, the two sections of debris followed separate trajectories. This fragmentation pattern is likely a key factor SpaceX is using to determine the final locations of the wreckage. These insights, drawn from the latest footage and technical analysis, offer a deeper understanding of the S-33 incident. However, many questions remain and further investigation will be necessary to uncover the full scope of what transpired. As SpaceX continues refining Starship, each test provides valuable data that brings the program closer to success. Future launches will undoubtedly incorporate lessons learned from S-33, improving the vehicle's design and reliability. The journey toward making Starship a fully operational spacecraft is filled with challenges, but each failure brings the program one step closer to its ultimate goal. So stay tuned for further updates as new details emerge. Moving on, exciting progress continues in the commercial space sector as VAST advances its space station development. The company has provided a significant update on Haven 1, the first module of its planned orbital outpost. VAST recently announced that Haven 1 has successfully completed its first major structural test, marking an important step forward in its development. In an update on X, the company stated, Haven 1's primary structure qualification article has passed a critical test milestone, successful proof testing on January 31st, 2025. This milestone was accompanied by a detailed roadmap and test results on the company's website, showing that the module was pressurized to 1.8 times its normal operating pressure. Additionally, leak tests were conducted to assess structural integrity. Max Hout, Chief Executive Officer of VAST, expressed confidence in the module's progress, stating, "On the first try, we passed that critical test." The company reported that the 48-hour leak test yielded an indiscernible leak rate, demonstrating the module's robust design and structural resilience. VAST's rapid progress is particularly noteworthy given that Haven 1 was only announced in May of 2023. The company has moved swiftly from design to fabrication, with the production process nearing completion. On January 14th, VAST released images of the fully assembled module and confirmed its transfer to a testing facility in Mojave, California. The next day, the module was lifted into its test stand, and after several weeks of preparation, the successful test was conducted as scheduled. Despite this achievement, Haven 1 still faces a series of rigorous tests before it is ready for launch. These include structural load testing and environmental simulations to ensure the module can withstand the conditions of its planned journey aboard a SpaceX Falcon 9 rocket. However, VAST's latest update did include one scheduling setback. The planned launch date has been pushed back from August of 2025 to May of 2026. Several factors contributed to this delay, including additional review processes, finalization of flight critical structures, expected by July of this year, and a series of integration and testing phases, most notably environmental testing at NASA's Neil Armstrong Test Facility in Ohio. While delays are always a challenge in the aerospace industry, the revised schedule indicates that VAST is committed to ensuring a thoroughly vetted and reliable system before launch. On a more positive note, VAST has confirmed that a crewed mission to Haven 1 aboard a SpaceX Dragon capsule is scheduled just 1 month after its deployment. If all goes according to plan, the mission will take place by the end of June of 2026, marking a major milestone for commercial space station operations. The deployment of Haven 1 is also crucial for VAST's larger ambitions. The company has introduced Haven 2, a more advanced and expansive module designed as part of NASA's Commercial Low Earth Orbit Destinations initiative. Unveiled in October of 2024, Haven 2 is expected to play a pivotal role in the second phase of the CLD program, which is set to commence in mid-2026. Max Hout emphasized the importance of Haven 1 in laying the groundwork for future expansions, stating, "We couldn't even bid a credible Haven 2 design if we had not done all this work in design maturation for Haven 1. Regardless of the CLD dynamic, that makes a lot of sense. Haven 2 will be structurally similar to Haven 1, but significantly larger. VAST envisions launching multiple Haven 2 modules, which will then be assembled in orbit. The plan includes an initial deployment of 4 modules, which will dock in a cross-configuration around a central hub launched aboard SpaceX's Starship. Additional Haven 2 modules will be launched subsequently to expand the station's capabilities. Despite the schedule adjustment, VAST remains ahead of other commercial space station initiatives, reinforcing its leadership in the race to establish the first privately operated space station. The project's success is critical as the International Space Station nears the end of its operational lifespan. The transition to commercial space habitats is essential to maintaining a continuous human presence in low Earth orbit. And now for our final bit of today's updates. Shifting focus to NASA's Artemis 2 mission, preparations for the first crewed flight of the Artemis program continue to make steady progress. On the 6th of February, NASA provided a key update regarding the assembly of the Space Launch System rocket. According to the agency, 8 of the 10 solid rocket booster segments have been successfully stacked. These newly placed segments, located in the middle of the booster assembly, feature NASA's iconic worm logo. With only the aft skirt, forward skirt, and nose cone remaining, one of the 2 side boosters is nearly complete. NASA has reiterated the importance of these boosters, which will contribute 75% of the total thrust required for Artemis 2's liftoff. Once the full stack is completed, the boosters will be attached to the SLS core stage, which was transported to the Kennedy Space Center last year. This will be followed by the integration of the upper stage and the Orion spacecraft, bringing the launch vehicle closer to flight readiness. Another important milestone for Artemis 2 is the completion of post-insertion and deorbit operations training at NASA's Johnson Space Center. During these sessions, the Artemis 2 crew trained on configuring the Orion spacecraft once in orbit, making it habitable, and preparing for their return journey from lunar orbit. The training included simulations of critical mission phases, ensuring that astronauts are well versed in the spacecraft's operations. NASA remains on track for an April of 2026 launch, but significant work remains. The Orion spacecraft, which will carry the crew around the moon, still requires extensive testing and preparations. With just over a year until launch, NASA faces immense pressure to finalize all systems and ensure mission success. Delays in the Artemis program have been a source of frustration for many, but NASA is committed to delivering a safe and successful mission. As preparations continue, the space community eagerly anticipates the return of astronauts to the moon for the first time in over half a century. Failures like S-33's loss are challenges that push spaceflight forward. Every test refines Starship, bringing it closer to success. Meanwhile, VAST's Haven 1 and NASA's Artemis 2 continue advancing, paving the way for humanity's future beyond Earth. The road to space is filled with obstacles, but each one overcome brings us closer to the next great leap. This has been Kevin with Great SpaceX. Thank you for tuning in. Stay curious, stay inspired, and until next time, keep looking up.